Okay, so this video is going to be over circular motion 4B, and this is going to be our last video for this semester of summer school. Yay! And this section has to do with what's called linear velocity or linear speed and period, and we're going to be combining equations in this section with the equations over centripetal acceleration and centripetal force that we saw before. So, just to recap. In the last video, we talked about centripetal force and centripetal acceleration, which an object must have in order to move in circular motion. There has to be that center-seeking force, that net force pulling or pushing the object towards the center of the circle. And the centripetal force depends on three factors: the mass of the object, the speed, v, of the object, and r, the radius of the circle. Now, practically speaking, radius and mass are easy things to measure. You can easily measure the mass of something by putting it on a balance. You can measure the radius of a circle by just, taking a tape measure or something like that, or a meter stick. Okay, but speed or velocity is very difficult to measure. And so what we're going to talk about now is something that can be used to calculate the speed, and then once you have the speed, you can plug back into this equation or into the equation for centripetal acceleration, which, just to recall, is v squared over r. Okay, and so we're going to see some multi-step calculations. Okay, and this concept is what's called period. So, here's how this works. Okay, please make sure you add this to your notes very carefully. Definitions are really important for you to know. What it says in the notes is that for an object moving in circular motion, the period of an object is defined as the time it takes that object to complete one rotation or one revolution. Okay, let me say it one more time. The period of an object is defined as the time, so period is a measure of time, it takes for that object to complete one single rotation or revolution. So, for example, the period of the Earth revolving around the Sun is 365 days. We call that a year. That's the time it takes Earth to go in one complete revolution around the Sun. The period of Earth rotating on its axis is 24 hours. We call that a day. The period of the Moon revolving around the Earth is about 28 days. That's why we have like cycles of the Moon. Now, you might think the symbol for period is a P, because period starts with P, but that's not actually the case. Capital P is actually used for power, which we'll see in the second semester of this class. Okay, the symbol for period is actually a capital T. And the reason it's a capital T is because, remember, period is a unit of, or a measurement of, time, specifically the time it takes that object to complete one full rotation or revolution. So, for example, I might say that the period of Earth is 365 days. I might write it like this. Okay, remember, capital T is the symbol for period. Now, don't confuse that with lowercase t, which is just time. Now, the unit for period in calculations is seconds. Now, you can write period in other units like we did up here, but when you do calculations, the unit for period is seconds. Okay, now, why is this important? Well, because if you think of our centripetal force equation, mv squared over r, it's not so easy to measure v. Okay, it's not easy to measure the speed or velocity of an object. If you look up at the moon, it's not like you can just look at the moon and automatically know how fast it's going. But what you can do is you can easily measure the period. Okay, all you have to do is watch the moon, keep counting the days until it ends up in the same spot, and then that time is one period. And so period is something that's very easy to measure, and as we'll see in just a second, can be used to calculate v, which can be then plugged into this equation for centripetal force, or into the equation for centripetal acceleration. Okay, so that's one of the purposes of period. So let's do some simple examples. Okay, so here are the examples. This first example says a merry-go-round takes 2.4 seconds to complete 2 full revolutions. What is the period of the merry-go-round? So remember, the symbol for period is a capital T, so that is our unknown. Now, it's really, really, really important that you know the definition of period because there's no possible way to answer this question unless you know the definition of period. This is not an equation thing. This is a definition thing. The definition of period is the time for one revolution or one rotation. So let's think about this logically. This merry-go-round makes 2 revolutions in 2.4 seconds. By definition, the period is the time for one revolution. So if it goes around twice in 2.4 seconds, think about that. How long is it going to take to go around one time? Well, clearly, hopefully you got that. That's going to be 2.4 divided by 2, which is 1.2. And so I would say the period of this merry-go-round is 1.2 seconds. And I would write the answer just like that. Now, if you don't know the definition of period, there's no possible way you can answer the question. So it's really important that you know what is meant by period. Okay, second example. A planet is observed to complete 4 full revolutions in 28 days. What is the period of revolution for the planet in days? Okay, so again, by definition, the period is the time to complete one full rotation or one revolution. If the planet goes around 4 revolutions in 28 days, how long does it take to go around once? Again, hopefully you got that. It's just kind of logical. Okay, if it goes around 4 times in 28 days, it's going to go around one time every 7 days. So I would say the period of this planet is going to be T, capital T is 7 days. That's how I would answer this question. Okay, so hopefully you have a better understanding of what is meant by period. Pause there if you need to look at that. Okay, so what can we do with this period that relates to previous calculations? Okay, so we know about, v squared over r and mv squared over r. Okay, so what we're going to do now is we're going to use period to calculate v. How do we do that? Well, so remember the very first thing we talked about on the first day was speed equals distance over time. Or I think we probably wrote it like d equals v times t, but that's the same thing as writing v equals d over t. Now, this simple equation lets us find an equation for v that has period in it. So if you have an object going around in a circle, if the time is 1 period, think about this logically. In 1 period, what distance does an object travel? If it's going around in a circle, what is the distance traveled in 1 revolution? Okay, it has a name, it starts with a C. Okay, hopefully you got that. That distance is called the circumference. And the equation for circumference is 2 pi r, where r is the radius of the circle. Okay, and so this is going to be our last equation, I believe. Okay, this equation allows us, if we have a if we know the period and if we know the radius of the circle, then we can find v. And once we find v, we can plug that into our other equations. Okay, so pause there if you need to write that down. So basically we only have 3 equations. We have this equation here, and we have centripetal force and centripetal acceleration equations. Alright, so let's do some examples and then we will be done. This is a short video. Alright, example 1. It says a ball is swung on a 1.5 meter long string. Notice they give us the length of the string. That's going to be the radius of the circle. Okay, notice it's measured in meters, such that it completes 20 revolutions in 10 seconds. Okay, first question says calculate the period of the bucket. Now, by definition, the period is the time it takes to complete 1 revolution. So let's think about this. If we have 20 revolutions in 10 seconds, how long is it going to take for 1 revolution? Okay, so think about that. Hopefully you figured it out. It should be 10 over 20, which is a half. Okay, so 0.5 seconds. That's going to be the period. Okay, that answers the first question. Second question says, what is the linear speed of the bucket? Anytime it says linear speed or linear velocity, those are the same thing. That is talking about v. Okay, so now that we have the period, we can use our V equals 2 pi r over t equation to answer the question. So we have 2 times pi. You can either use the pi button on your calculator, or if you don't have a scientific calculator, you can use 3.14, even though that's just an estimation. The radius is 1.5. We found that before. And now we're dividing by the period, which is 0.5 seconds. Okay, so I go to my calculator. I have 2 times pi times 1.5 divided by 0.5. I'm using the pi button on my calculator, so your answer might be slightly different, but I get 18.8 meters per second. Okay, and so that is the speed of the bucket. That is the linear velocity of the bucket, whatever you want to call it, that is V. Now, we've seen this bucket situation before. Okay, bucket being swung around, or it says a ball actually in the problem. I just realized it switches from ball to bucket. Sorry about that. It should be a bucket. So just, ignore that little mistake there. My bad. Okay, so we've seen this situation before where because it's being swung on a string, the string is providing the centripetal force. Okay, the force of tension from the string is acting towards the center of the circle. So when it says to calculate the tension in the string, because the tension is towards the center of the circle, this is really asking us to calculate the centripetal force. Okay, the centripetal force equation is mv squared over r, and now I have everything to plug in. I have the mass of the bucket, which I just realized is not given. Oh gosh, what a horrible mistake. So number one, it's a bucket, not a ball. Number two, it looks like I forgot to give you the mass. So let's just make up a mass. I'm going to completely make up a number. Let's say the bucket has a mass of 4 kilograms. Okay, sorry about all my mistakes. Okay, so let's say it has a mass of 4 kilograms. So we have 4 times 18.8 squared. Remember, only v is being squared, so you have to square that 18.8 first before you multiply and divide. And then we want to divide by 1.5. Now, if you type that into the calculator correctly, 18.8 squared times 4 divided by 1.5, you should get 942.5 newtons. Okay, 942.5 newtons. That is the tension in the string. Alright, so that is example 1. Okay, pause there if you need to look at that. I'm sorry for all the mistakes and having to make up the mass off the top of my head. I apologize for that. Okay, we're going to do one more example and then we will be done. Okay, last video of the semester. Example 2. Okay, now we have another bucket of water. That's great. Exact same situation. So let's see. Now we're given the mass of the bucket. That's good. The mass of the bucket is 2 kilograms. The rope has a length of 0.5 meters. By the way, it's a complete coincidence that I gave you 2 bucket problems in a row. Okay, there's lots and lots of situations involving period and centripetal force that I could have given you. It just so happens that the 2 I gave you just happened to involve a rope. Okay, so I don't want you to think, oh, the centripetal force is always tension. No, it's a coincidence. Okay, so again, I apologize for that coincidence. So we do have the radius. The bucket takes 8 seconds to go around 2 times. Okay, so immediately, hopefully you can do that mental math. The period that you should find is 4 seconds. Remember, the period is the time to go around 1 time. If it goes around 2 times in 8 seconds, that means it takes 4 seconds to go around 1 time. From the period, we can find v, okay, the linear speed. That's 2 pi r divided by t. Okay, remember, t is the symbol for period. So we have 2 pi times 0.5 divided by 4. Again, I go to my calculator. Okay, and I'm using the pi button on my calculator, so you might get a slightly different answer, but I get 0.79 meters per second. Okay, it's meters per second because that's V. And now we want to find the tension in the rope holding the bucket. This is exactly like example number 1. Okay, the formatting is very, very similar. Centripetal force is mv squared over r. Okay, so I'm going to do the mass, which is 2 times 0.79 squared divided by 0.5. Okay, and I'm going to round that to 2.5 newtons, and that's going to be my answer. That is the centripetal force, which is provided by tension. Okay, and so because the tension in the rope is providing the centripetal force, that means the tension in the rope is also that 2.5 newtons. Alright, so pause it there if you need to look at that some more. If you have any questions, please let me know. This is the last video of the first semester in summer school physics, so I hope you enjoyed everything. If you are taking the second semester, I will see you guys in the next semester. Otherwise, have a great rest of your summer. See ya.